Next part is to find the angle between two straight lines. The first step is to find the direction vector v1 and v2 for these two lines. And the second step is to use dot product in order to find the angle between the two vectors. So here we have L1, which is R1 plus A1 plus dV1. So this means that along L1, there is the direction vector V1. And we also have another line L2, R2 equal to A2 plus SB2. And on this line, it has its own direction vector V2. So make sure when you draw the vector, both vectors must go out. And hence we can find the theta between the two vectors. So we want the angle theta between this L1 and L2. And note that it is the same as the angle theta between V1 and V2. So since we have V1 and V2, we can find the angle of theta by using the scalar product. And if you rearrange this, you can find the angle theta, which is cos inverse V1 dot V2 divided by the magnitude of V1 and V2. Example 12, question 1. Given the line P, so this will be our first line L1, and another line that passes through 2, 1, negative 3 in the direction 3, 1, minus 2j. So this will be L2. And we want to find the acute angle, which means we want to find the angle theta, which is less than 90 degree between the two lines. So since we have two lines, therefore we need to find two vectors, which is V1 and V2. Don't forget, the direction vector always come together with the parameter, which is m in this case. For L2, we know that the line passes through this point, which is fixed, in the direction 3i minus 2j. So if you have the word in the direction, this is the direction vector v. We can use t because here in L1 we have m. So we can use t here for L2. So now we're just going to substitute. A2 is 2, 1, negative 3. And V2 is 3i minus 2j. So let's change R2 to become Q. Step 2 is to find theta by using the dot product. So don't forget that the angle theta is between V1 and V2. That's why here you have V1, V2, V1, V2. So we can see that the final answer is theta equal to 65.67 degree, which is an acute angle since it is less than 90 degree. And that is how we solve this question. We are given two lines, L1 and L2, and we want to find the angle between these lines, which means that we need to find the angle theta. Step 1 is to find V1 and V2. So for L1, we have this information, and note that if you look at VPC, this is actually the Cartesian equation. So in order to find V1, you need to change it back to VE. So from CE, you need to change it back to PE first. And to get PE, you need to find the value of t from this equation. So the first one is x equal to 1. Next is y plus 2 over 3. Oh, sorry. X equal to 1 is actually 1 plus 0t. Next is z minus 1 over 2. And this is PE. Next, we need to change it back to vector equation. The second step is to find theta by using the scalar product. And hence the angle between these two lines is 142.1 degree. So if you look at the question again, the question just says find the angle. It doesn't say find acute angle. So if it says you must find acute angle, you must make sure that your angle should be less than 90 degree. But in this case, it doesn't say anything about your angle. Therefore, we're just gonna take this answer as our final answer. But what if the question wants acute angle, but you only have theta is 142.1 degree, which is definitely bigger than 90 degree. So what you're gonna do is, you need to make sure where is this angle here in quadrant. Therefore, 142.1 degree is somewhere in between 90 and 180. Therefore, this angle theta here is in the second quadrant. But since we want to write our answer as an acute angle, look at the second quadrant here. You can see that the acute angle is here. So we need to find this angle by using the formula 180 degree minus 142.1 degree. And thus, the acute angle theta is 37.9 degree. So that's how you find an acute angle when your theta is definitely not in the first quadrant. So this means that you need to draw your quadrant first and then determine where is your angle in the quadrant. Is it in the first quadrant, the second, the third, or the fourth? So depending on the quadrant, you need to apply the corresponding equation in order to find the acute angle.